So addition of binary numbers is actually not really that different than the addition of decimal numbers in the same way that you've probably been doing since about grade 4. So if you had two decimal numbers like 23 and let's make it 58, if I were to add those two together on paper like this, I add 3 to 8, that makes 11, doesn't it? 3 plus 8 is 11. And remembering if it adds up to more than a single digit, so you need 2 digits to represent 11 in decimal, then you carry the tens. So 3 plus 8 is 1 with a 10 carried. And now we add these 3 together. So we've got 1 plus a 2 plus a 5, that's 8. Okay, so 23 plus 58 is 81. Any calculator will tell you that. However, the method that you would use, if you were writing it down on paper and you were probably grade 5, is you add the digits one at a time, or two columns at a time like this, and if you get more than 10 on the bottom here, you have to carry the tens across. Okay, it's not very different from adding binary numbers, except now if you've got a binary number and each digit can only have 2 different numbers, can't it? It can only be 0 or 1. So if I had 2 binary numbers like this, and I were to add them together, I can do very much the same thing. 1 plus a 0 is just a 1. Good, I can represent that completely. It doesn't matter what's to the left of it, just that 1 and a 0, I can represent that in 1 digit, so that's fine. But a 1 plus a 1, well that's 2, but 2 in binary is 1, 0. So I can't represent the 2 here with a single digit. So what I need to do is put the 0 there and carry the 1. And so now I've got 3 to add here. 1 plus a 0 plus a 1, well that's 2 as well, which is 1, 0. Now we've got a 1 plus a 1 plus a 1, that's 3, which is a 1, 1 binary number. Okay, so 1 and, well, if there was nothing here, you could pretend that there's a 0 there, and carrying the 1 plus a 0 plus a 0 is another 1. So if I were to add this binary number and this binary number together, incidentally that is 8 plus 2 plus 1 is 11. So this is 11 in decimal, and this is 14 in decimal. Okay, so 11 plus 14 is 25 in decimal. Does this add up to 25? This is 16 plus 8 plus 1. 16 plus 8 is that's 24 plus 1, 25. Okay, so it does check out. Alright? So it's the same idea as adding. When you add with decimal, you carry the tens, or you carry the, each time you have to carry, that you go over 9 as the sum of those 2 digits, or 3, then you have to carry the 1 that you would get. Likewise with this, you have to carry, if it represents, if you need more than 2 digits, more than 1 digit to represent each bit. Alright, that one I think is pretty straightforward. Now, subtraction is a different kettle of fish altogether. Now, there's 2 ways you can do subtraction, and I'd be happy with you to do either. So, if I were to have two numbers and I were to subtract them, and let's just choose, I'll do decimal ones first, so let's do 14, and I'm going to subtract 9. Okay, 14 take 9 we know is 5. Right, so this is what we're going to be looking for in our binary number. Now, 14 is 1, 1, 1, 0, and 9 is 1, 0, 0, 1. Okay, so if I were to subtract these two, well, in decimal you kind of borrow, don't you? If I need to subtract a 1 from a 0, I've got to borrow from the next column, right? But we won't use that method. We'll use something called 2's complement to do it. I'm also quite happy if you if you're presented with this problem, if you were to convert it to decimal, do the subtraction and then convert it back to binary, that's acceptable. In the exam, I think you'll find that that's acceptable. However, it is good to know how to do the 2's complement method. Okay, so what 2's complement is, well, there's a couple of ways of doing it. I'll show you the extended way. There is a shortcut, and I can show you the shortcut later if you want. The extended way is you take the number that you're subtracting, okay, and what you do is you flip every bit. So if it's a 1, you write it as 0, and if it's a 0, you write it as 1, and then you add 1 to it. Okay? And so you add 1 to it, and that would be 0, 1, 1, 1. And now what you do is you add the 2 numbers together. So that now the sum is like that. Okay, so you're flipping and you're adding 1. So this is the 2's complement. Well, this is the 2's complement of that. Of that. And now then you add the 2's complement to the initial sum. So we get 1, this is 0, 1, and 0. Right? And importantly here, you have to discard the preceding 1 here. So this one goes away. So okay, so you discard that preceding 1, and so the answer is 0, 1, 0, 1. And that checks out to be 5, doesn't it? 4 plus 1 is 5. Okay, so the 2's complement method, what you do is you take the number you're subtracting, you flip all the bits on it, so where it's a 0, it's a 1, where it's a 1, you write a 0, and then you add 1 to that. And then you add, so that becomes the 2's complement of the number you're subtracting, and then you add that to the initial number. Okay? I won't explain why this works. That's the extended method. There is a shortcut to do the 2's complement. I won't explain that because I think it's confusing, or it can be confusing. So you can do it either way. You can do it by converting to decimal, doing a subtraction, and then convert it back to binary, or the 2's complement. And what's actually probably a pretty good idea is if you do the 2's complement, is to check out that you actually have a check it by doing the decimal conversion as well. So you can always check your work with these. Right? Now you're only allowed a scientific calculator in the exam, so those of you with calculators that can do conversions to binary and stuff, you won't be allowed to have that calculator with you. So that's a bit of a shame, but that's how it is.